Hi, to start today, I'd like you to write 168 as a product of its prime factors. Right, let's do this. So, it's not easy factors going into 168, other than maybe 2, so that seems a good shout. And then it's going to be 2 times 84. Let's do 2 again. That's going to leave us with 42. Okay, and then this is a number in the times tables, so it's going to be 6 and 7, and 2 and 3. So 168 is equal to 2 times 2 times 2 times 3 times 7. It doesn't say to do it in the index form, but make sure you can do that. 2 cubed times 3 times 7. Don't forget, if this was a calculator question, you can check it. You can put it into your calculator, 168 equals, and then shift and fact, and we get it there as well in index form. I'm going to be building on this today by looking at factors and the highest common factor. Talk more about that in a minute. First of all, I just want to talk about factors. So you can get your prime factors by doing factor trees, but you can also look at non-prime factors once you got your product of prime factors. Because 60 is 2 squared times 3 times 5, if we circle the 2 squared, actually we see that 4 is in fact also a factor of 60 because 2 goes into it once and twice, and 6 goes into it because 2 and 3. And if we draw a Venn diagram as shown, then you can see the red ones are when I circle, the 4 comes from when I circle the 2 and the 2, and the 6 comes from when I circle the 2 and the 3. So what I'd like you to try and find some other ones. Can you find any other factors using this method? Pause the video, try this out. Well, 5 and 3 you could put together to get 15, 5 and 2 to give 10. There's actually a lot, so here are all of them. Okay, you could even multiply all of them together to give 60. Don't forget, 1 is also a factor. You don't get that from the Venn diagram, but just be aware of that. Is 15 a factor of 2 cubed times 3 squared times 5? Thinking about what we've just been talking about. Well, 15 is 3 times 5, and we can see that 3 goes into this, and 5 goes into this, so yes, it's true. What I'd like you to do then is draw a Venn diagram of the prime factors of 168 and use this to write down all of its factors. Give a little hint, we did this one at the start, so it's 2 cubed times 3 times 7. Alright, Venn diagram, 2, 2, 2, 3, and 7. We're going to get quite a lot here. First of all, don't forget, we've got all the prime factors, so I might just write them down actually, as well as 1, 1, 2, 3, and 7. I might make a mistake here and not get them all. I just want to kind of wanted to get you practicing a few more. So I could get 2 and 2 could go together. 2 and 3, maybe this is a good strategy, and 2 and 7. 2, 2, 2 would work. 2, 2, and 3 would work, so 4, 12. 2, 2, and 7 would work, so that's 4 times 7, 28. Okay, I'm not finding them in pairs now, but you know, this question was basically just find as many factors as you can. 8 times 7 is 56. 7 times 3, I didn't do that one, 21, and I think the list, you know, there's actually quite a few. I'm just trying to figure out how many there are. There are ways of working out how many factors there are. I think there's 16 factors. I'm not going to talk about where I got that from. Don't forget you get 168 as well. Shall I keep going? How many have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's another 3 out there, so I'll leave it as a challenge for you to find those. But the demonstration is really that once we've got the Venn diagram, it's actually quite easy to write down a lot of factors. Still quite tricky to write down all of them, because in this case there are 16. Now, this is going to link into the main idea for today. We talked about non-prime factors, essentially. We've also talked about prime factors, just to revise that. Now we're going to talk about the highest common factor. So, just to say, we know what factors are, the numbers that go into it. A common factor is a shared factor. For example, 2 goes into 12 and 2 goes into 18. So 2 is a common factor of 12 and 18. But what is the highest common factor? What is the largest number that goes into 12 and 18? Well, 2 does, but also 3 does, and actually the highest one is 6. Okay, and you might get that. There's a few ways you can do it. You might write them all down, or you might sort of think about it like I've kind of done there. There is no higher one, because actually the next highest factor that goes into 12, I think, is 12, and that doesn't go into 18. But I just want you to give this a go. Can you have a go at finding the highest common factor of these other numbers? So whatever strategy you've got, you might maybe just try some numbers out until you think that's the highest one. But for this one, it's 9. For this one, it's actually 8. 8 goes into 8 and into 24, so sometimes that can happen. 144 and 216, the answer is actually 36. I wonder if you managed to get that. So which question was the most challenging? I think it's probably this one, because the numbers are much bigger. So we're basically now going to be looking at a better one. Rather than just sort of looking at it and trying to figure it out, we're going to have a nice systematic way of working out the highest common factor. Let's do this. So when we've got large numbers in particular, I know it's not quite the case here, but I'm using it to demonstrate it. We can use the prime factors to help us work out the HCF. 30 is 2 times 3 times 5. 42 is 2 times 3 times 7. Which prime factors are common in both numbers? Well, they both got 2 and they both got 3. Is there a larger common factor that isn't prime? And yes, there is. It's actually 6. 6 goes into both of them. How does this compare to the common prime factors? Well, it's actually the 2 of them multiplied together. Because 2 goes into both of them and 3 goes into both of them, it must be that 6 goes into both of them. So basically, the shared prime factors we can multiply, and that is going to be our method for working out the highest common factor. Really powerful method that we can use. So here's an example in full. Find the highest common factor of 48 and 60. We do our prime factorizations, and let's just say we draw our Venn diagrams for 48 and 60. If we overlap the Venn diagrams, what would we possibly place in this intersection part for the common prime factors? Well, they've both got 2, so I'm just going to cross them off and put 2 in the middle. They've both got 2 again though, so I'm going to put them in the middle again. And they've both got 3. 48 then has another 2 and another 2, while 60 has a 5. So that is a Venn diagram representation of the shared, the prime factors, the ones in the middle being shared. What do you think the HCF is? Well, 2 goes into both of them, but 2 goes into both of them again, and then 3 goes into both of them. We multiply these together. 2 squared times 3 equals 12. That is the highest common factor. Now that actually is method 1 for how to do this. I want to show you another method. You might prefer it. So I'm going to write 48 as 2 times 2 times 2 times 3. Oops, I think there was another 2. Again, that's from the prime factorization. And then 60 is 2 squared times 3 times 5. Okay, a really neat way of working out the HCF is to actually circle the common ones, like so. And then the HCF is going to be 2 times 2, because I can see it goes into it twice, times 3, which is 12. So you can decide, do you want to draw a Venn diagram, or do you want to line it up this way? The even quicker way, I'm only going to talk about this very briefly, is to kind of look at the lowest power. Look, I can see that 2 squared goes into both of them, but this is the lower one. And I can see that 3 goes into both of them, and that's it. So I could then just do 4 times 3, which is 12. That's the really quick way. I'm going to take a bit more time, get a Venn diagram down, or line them up like so. Right, I'd like you to find the HCF of 140 and 210. Try it this Venn diagram way, and then see if you can think about the other methods I spoke about. Pause the video, try this out now. So shared factors, we've got 2. I might just kind of cross out as I go along. 5 and 7, which leaves us with 3 here and 2 here. So the highest common factor is just going to be 2 times 5 times 7, it's 70. You might have spotted that really quickly. It's just another, you might be able to see it, but it's a way of doing it that's going to work well for larger numbers. Method 2 is to write them out in full. Now I like to kind of take it a bit at a time, make sure they're ordered. So I'm going to put the 3 here and line the 5s up. You've got to leave little gaps if they don't have it. So we've got the 2, the 5 and the 7, and we again get the same answer. How about this one? Find the HCF of these. Well, actually, this is where I kind of start. I'm not a fan of the Venn diagram because it just ends up being quite complicated. Whereas if you write them down, notice the way I'm kind of writing them down together, just making sure I am lining them up. Just check that they look okay. Yep. Okay, in this case, the HCF is equal to 2 times 2. You might even be asked to leave it in index form, especially if it was to become really big. But in this case, I'll work it out. So I'm going to get my 2 times 5, which is 10. It's going to be 60. So sometimes we could be asked to find the HCF of things written in index form. We might even be asked to leave our HCF in index form. I hope you're happy with this. So we've talked about the HCF. I've given you 2 main methods for how to do it. You decide, do you want to use Venn diagrams? You've got to remember to use this middle bit, the intersection, but hopefully you've got this understanding of what's going on. The fact that 2 goes into both of them, 5 goes into both of them, 7 goes into both of them. So if I multiply those together, that number will also go into both of them and will be the highest common factor. The same goes for this technique here. So what I'd like to do is try these ones yourselves using the, don't try and just guess what it is, use one of the 2 methods that I've given you. Especially important for later ones. here are the answers. That one looks very similar to the one I did here, but they are different numbers. And then just to test you, what's the highest common factor of 540 and 480? Well, I'm going to do this one the quick way, so I can see that 2 squared goes into both of them, but that's going to be the highest. 3 goes into both of them, that's the highest. And 5 goes into both of them. So it's again going to be 60. I'll leave you finally with a little extension on lowest common factors. You'll be asked about highest common factor in a GCSE exam, but now we're just going to look at lowest common factors of many numbers. And actually, in general, they're going to be 1, so we're going to ignore that. So because 1 would be the lowest common factor of these numbers, but what about the next highest one? Okay, that's the rule. So I'm just going to pick this one here. We're trying to find something that goes into 48, 20, 14, and 38. That is the lowest possible thing. Well, I can see that they're all even. So actually, I think the answer to this one's going to be 2. And you have to proceed with all the other ones. Once you get to the end, you can actually try and find a triangle number. You may or may not be familiar with them by dividing the sum of the 2 largest factors in the grid by the product of the 2 smallest. Try and see if you can get that. Well, the answer to that last bit is actually 6, which I'll explain, but if you got 6, then you probably did the whole thing correctly. Here are the answers. So the 2 largest are 17 and 19. Sum means that you add them up, give 36, and then we divide by the 2 smallest, 2 and 3, and we get 6. And why is it a triangle number? Because when I line up dots like this, I get a little triangle, as opposed to, say, square numbers, where I put them into little squares. So 4 is a square number, 6 is a triangle number. Well done if you tried this extension, and well done on your practice of highest common factor.